In section 1-2, we're going to talk about functions. So what you should learn is to determine whether a relation between two variables represents a function, use function notation and evaluate functions, find domains, and then use functions to model and solve real-life problems. So just a few reminders about what a function is. We have the formal definition here. And what this formal definition says is that if you have a set A, from set A to set B, that each element, and we use the letter X just because that represents that X-axis. So each element X in set A has exactly one element Y in set B, where A is your domain. So your X's are usually your domain and your Y values are your range. And so what this means is that your X values can't repeat, and that each X value is matched with exactly one Y value. But your Y values can repeat. Okay. If you were visually looking at a function, so remember that if you were looking at a graph and determining if your graph was a function, it has to pass that vertical line test. So if you were to draw a vertical line, it can only go through your graph one time. And that's really what this says. Each element A is matched with B. Some elements of B may not be matched in A. So you might not have every Y value, and two or more elements of A may be matched with the same element of B. So what this means is if we were looking at points, we could have a point 1, 2, and we could also have the point 3, 2, where each one, your Y values could actually show up more than one time. So to determine whether or not a relation is a function, you have to decide if each input value, and your input are usually your domain or your X values, is matched with exactly one output value or your Y values. So if we look at this little chart here, if our input is 1, 2, 3, 4, 5, 6, and those are each matched with the 9, 10, 12, 13, 15, that would be a function because your X values have exactly one Y value, or your X's don't repeat. So looking at this chart here, if we look at our input, if you notice the X or the input occurs twice, and it's for two different Y values. So visually, if you were to think about what this looks like, if you were to graph the point 211 and then graph the point 210, they would vertically sit right on top of each other. So if you were to draw that vertical line, it would pass through 2 points, which means it doesn't pass that vertical line test, or it's not a function. If we were to look at the graph in part B here, and if you look at it in terms of does it pass the vertical line test, none of the points stack up vertically, so this would be a function. Now, if we're given equations and we're just asked from the equation to determine if this equation represents a function, there's a couple little shortcuts that you can look at. So in this case, we would consider y to be our dependent variable. So if y is your dependent variable, or your range, right? So if your dependent variable has an odd degree, so like 1, 3, 5, 7, then it will represent a function. Because what happens is if we were to solve the equation for y, and we would have y equals negative x squared plus 1, hopefully you know that this is a parabola that just opens down, right? So that would represent a function. Now, if your dependent variable has an even degree, then it's not going to be a function. But you have to be careful that you don't get that dependent and independent switched. So here, if we were to solve for the y, we would have y squared equals x plus 1. And if we were to solve for y, when you take that square root of both sides, you need the plus or minus. And so when you get that plus or minus, what happens is that if you were to graph that plus and the minus, you get a graph that looks like this, right? Which wouldn't pass that vertical line test. But without even having to graph them, you really can just look at what that dependent variable is, look at its degree, and then determine is it odd or even, and will you end up with a plus or minus when you solve for that actual variable. And then we have domain and range. So one thing you need to remember is your interval notation. And remember, interval notation has the parentheses and the brackets. So if you use a parenthesis, that means it does not include the number. And if you use a bracket, then it does include the numbers. The numbers always go from the smallest on the left to the largest on the right, and make sure that you never include infinity. So infinity will never have a bracket next to it. So if we were trying from our notation here where x is between 3 and 6, it doesn't include 3, but it does include 6, we would have a parenthesis with the 3 and then a bracket with the 6, and we would know that that's our interval notation from 3 to 6. If x is greater than or equal to 3, that means 3 is our lowest number, it includes it, and it would go to infinity, and you would use a parenthesis. You can't use a bracket with infinity because you can't physically graph a point at infinity. It's more of that concept that it will continue to grow, so we put a parenthesis there. And then just this reminder about function notation. So if we have a function here, negative x squared plus 4x plus 1, and we have to find g of 2. So remember, g of 2, whatever is in this parenthesis, is what we're plugging in for any x value. So we're going to have negative 2 squared. And notice that this negative is outside the squared. It's not being squared, so we would keep it outside. Plus 4 times 2 plus 1. So you'd get negative 4 plus 8 plus 1, which would give you 5. In the second part, this g of t means we're just substituting a t in for our x's. So we'll have negative t squared plus 4t plus 1. And then on the last one, where we have g of x plus 2, then that means wherever we have an x up here, we're replacing it with an x plus 2. So we're going to have a negative x plus 2 squared plus 4 times x plus 2 plus 1. Remember to leave that x plus 2 in parentheses so you remember that you either need to distribute or FOIL. When you square this right here, you cannot distribute a squared. You actually have to FOIL it out. So remember, that's like saying x plus 2 times x plus 2. And so if you FOIL that out and then distribute your negative, well, first you FOIL it out, you get x squared plus 4x plus 4. So we'd get negative x squared minus 4x minus 4. Going back up here, distributing the 4, we get plus 4x plus 8 plus 1. And then we need to simplify that. So you would get negative x squared minus 4x plus 4x becomes 0. And then you have a minus 4 plus 8 plus 1, which gives you plus 5. So that would be your final answer there. You would put that into simplified form. Then we have the domain of a function. When you have square roots, remember that your domain excludes x values that result in roots of negative numbers, even roots of negative numbers. So if you had the square root of x, x would have to be greater than or equal to 0, or you would say from 0 to infinity. You can include 0 because you can take the square root of 0, but we couldn't have any negatives in there. Also remember that the domain of a function is restricted in certain circumstances. You have to restrict the domain if you have something under a square root symbol or potentially in the denominator. So if you have a square root or an even root, or you have a fraction, you're really going to have to look to see if we need to restrict that domain. So an example would be if we have the square root right here of 16 minus x, then we know that 16 minus x has to be greater than or equal to 0, which means that x has to be less than or equal to 16. And so if we were writing that in interval notation, then we would know that we could have any number from negative infinity to 16 as part of our domain. If you look at this other one, g of x, we have our denominator, the 15 plus x, so we know that x can't be 15, but here if you notice we also have that square root in our numerator, so we would have to also consider the fact that x plus 15 has to be greater than or equal to 0, or x has to be greater than or equal to negative 15. But we know it can't include negative 15 from this part, so if we were writing our domain, we would say that we know then the x just has to be greater than negative 15, since it can't equal 15 from the denominator, or we could say negative 15 to infinity for our domain. We also have piecewise functions. So piecewise functions are almost two functions that come together, but they have two separate domains. So in this first example, if we have values for x that are less than 0, we're going to use x squared plus 1. If we have values for x that are greater than 0, we're going to use x minus 1. So if we're evaluating the function, we'll first start with when x is negative 1. So if x is negative 1, so if we're doing f of negative 1, we would say negative 1 is less than 0. So we're going to use x squared plus 1. So f of negative 1 would be negative 1 squared plus 1, which would just give us 2. If we're looking when x is 0, we'd say f of 0. 0 is included in the bottom part of the function. So if we plugged a 0, we would say 0 minus 1, which would give us negative 1. And when x is 1, that's still included in that second part of your piecewise function. So f of 1 would be 1 minus 1, which would equal 0. And then the last thing is finding the domains of functions. So remember, your domains are usually your x values. When you're given the set of points, your domain, you're just going to list your x values. So your domain would just be negative 3, negative 1, 0, 2, and 4. In B, when we have a quadratic, so you have to think for domains, is anything restricted? Or if you were graphing this, would there be any restrictions on what you could plug in for x? And because you're allowed to plug anything in for x, for this one, your domain would be all real numbers. Or in interval notation, we would say your domain goes from negative infinity to infinity. And then for part C, we have the fraction. So remember that we know that x plus 5 cannot equal 0 since it's in the denominator, which means that x cannot equal negative 5. So you could say that your domain is all reals not equal to negative 5. If we're using interval notation, we would have to set up two intervals. So we would say negative infinity to negative 5. We don't include it. And then we start again from negative 5 to infinity. So because we use those parentheses there, that would exclude negative 5 from our domain.